Good morning. So today we will continue the problems on vector algebra. Yesterday we have seen the 4 problems. So today let us see the 5th one. Here we are given the 3 vectors a bar, b bar and c bar, and we are asked to evaluate the vector triple product of these 3 given vectors a bar, b bar and c bar. So a bar is expressed as I cap plus 4j cap minus 2k cap. B bar is expressed as j cap plus k cap, and c bar is expressed as I cap minus j cap. Then you are asked to evaluate a bar cross b bar cross c bar. We have said that the vector product of these 3 vectors is a vector quantity. So before we evaluate a bar cross b bar cross c bar, let us first obtain the vector b bar cross c bar. As we know that the cross product of the 2 vectors, say b bar and c bar, is expressed in the form of a determinant. The first row of the determinant constitutes the unit vectors I, j, k. The second row of the determinant is the components of the first vector in the product, and here the first vector in the product is b bar, and b bar is expressed as j cap plus k cap, so that the coefficient of I cap here is 0. So the second row of the determinant will be 0, 1, 1. And the third row of the determinant is the components of the second vector in the product. The vector c bar is expressed as I cap minus j cap, so that the coefficients, the components of c bar will be 1, minus 1, 0. So if we evaluate this determinant, it will give us I cap into bracket 0 plus 1, 0 minus minus 1, so it is 0 plus 1, minus j cap into bracket 0 minus 1 plus k cap into bracket, it is 0 minus 1. So this works out to be equal to 0 plus 1 is 1, so it is I cap. 0 minus 1 is minus 1, so minus of minus becomes plus, so it is j cap, and 0 minus 1 is minus 1, so it is minus k cap. So the vector b bar cross c bar works out to be I cap plus j cap minus k cap. Now we are asked to evaluate the vector triple product of the vectors a bar, b bar and c bar. So let us replace this vector b bar cross c bar by a vector d bar, so that a bar cross b bar cross c bar is nothing but equal to a bar cross d bar. This b bar cross c bar is replaced by d bar, so we can express it a bar cross d bar. And again, this cross product a bar cross d bar can be expressed in the form of determinant. The first row is the unit vectors I, j, k. The second row is the components of the first vector in the product. The first vector in the product here is a bar, so that the components of a bar are 1, 4, minus 2, and the third row of the determinant is the components of the second vector in the product, that is d bar, that is of b bar cross c bar, and the components of b bar cross c bar are nothing but 1, 1, minus 1. So if we solve this determinant, it can be expressed as I cap into bracket minus 4, minus of minus 2 is plus 2, so it is minus 4 plus 2 minus j cap into bracket minus 1 minus of minus 2 minus 4 plus 2 here it is minus j cap into minus 1 plus 2 minus 1 plus 2 plus k cap into bracket it will be 1 minus 4. So this works out to be equal to minus 4 plus 2 is minus 2 I cap minus 1 plus 2 is plus 1, so it is minus j cap, and 1 minus 4 is minus 3, so it is minus 3k. So we get the result of this vector triple product a bar cross b bar cross c bar to be equal to minus 2 I cap minus j cap minus 3 k cap. So that is how we can evaluate the vector triple product of the three given vectors a bar, b bar and c bar. So let us see the next problem. The sixth problem is show that you are asked to show that a bar cross b bar cross c bar plus b bar cross c bar cross a bar plus c bar cross a bar cross b bar is equal to 0. You are asked to show that the sum of the vector triple products of the vectors a bar, b bar and c bar when taken in cyclic order works out to be equal to 0. So to prove this, let us consider the expression for a bar cross b bar cross c bar. We have a bar cross b bar cross c bar is equal to, we have seen the back-cab rule. While expressing the cross product of these three vectors, when is expressed in terms of the components of these three vectors, it works out to be a back-cab rule. So this vector triple product a bar cross b bar cross c bar is expressed as b bar into a bar dot c bar minus c bar into a bar dot b bar. BAC minus CAB, back cap. So this is how we express the vector triple product of the vectors a bar, b bar and c bar when taken in this cyclic order a bar cross b bar cross c bar. Similarly, we can express b bar cross c bar cross a bar, and this will be equal to b bar cross c bar cross a bar will be equal to c bar into bracket b bar dot a bar minus a bar into bracket b bar dot c bar. Remember the sequence. Similarly, we can express c bar cross a bar cross b bar is equal to a bar into c bar dot b bar minus b bar into c bar dot a bar. So this is how we express the vector triple product of the three vectors a bar, b bar and c bar when taken in the cyclic order. And now here you are asked to prove that the sum of these three vector triple products works out to be equal to 0. So let us evaluate the sum. So therefore, sum is equal to, sum means this given sum, a bar cross b bar cross c bar plus b bar cross c bar cross a bar plus c bar cross a bar cross b bar. This sum is equal to. So use these expressions for a bar cross b bar cross c bar, b bar cross c bar cross a bar, and c bar cross a bar cross b bar. So this is nothing but b bar into a bar dot c bar minus c bar into a bar dot b bar plus c bar into b bar dot e bar minus a bar into b bar dot c bar plus a bar into c bar dot b bar minus b bar into c bar dot e bar. So this is the sum. While studying the properties of the scalar product, we have seen that, or the dot product, a bar dot b bar is equal to b bar dot a bar. So we have this identity that a bar dot b bar is equal to b bar dot a bar. And again, if we using this property here, so either we can replace a bar dot b bar by b bar dot a bar, or b bar dot a bar by a bar dot b bar. So here, if this b bar dot a bar is replaced by a bar dot b bar, so this term is minus c bar into a bar dot b bar, and this term is plus c bar into a bar dot b bar. So these two terms will get cancelled. Then again, here we have the second term, b bar into a bar dot c bar plus, and this is the term minus b bar into c bar dot a bar. Again, here if we use this property that a bar dot c bar is equal to c bar dot a bar, what we can write is this term and this term will again gets cancelled. So these two terms will cancel. Similarly, here we have the term a bar into c bar dot b bar plus, and here we have the term minus a bar into b bar dot c bar, and again using the same property, here we can replace either b bar dot c bar by c bar dot b bar, or c bar dot b bar can be replaced by b bar dot c bar. So one term is positive, the other term is negative. So again these two terms will get cancelled. So what is the sum? The sum works out to be equal to 0, which means to say that the sum a bar cross b bar cross c bar plus b bar cross c bar cross a bar plus c bar cross a bar cross b bar, this works out to be equal to 0, and that is what we are asked to prove. So that is the next problem. So let us see the next one. Seventh problem. Find the angle between a bar equal to 2i cap plus 2j cap minus k cap, and b bar equal to 6i cap minus 3j cap plus 2k cap. You are asked to find the angle between these two vectors a bar and b bar. So as we know that the dot product of the two vectors A bar and B bar is expressed as the product of magnitudes of the two given vectors and the cosine of the angle between them. So A bar dot B bar is equal to AB cos theta. Here A and B are the magnitudes of the two given vectors and theta is the angle between the two given vectors. So from this we can express cos theta to be equal to A bar dot B bar divided by mod A bar into mod B bar. So let us first obtain the dot product of A bar and B bar, the magnitude of A bar and magnitude of B bar. So the dot product of these two vectors A bar dot B bar is expressed as 2i cap plus 2j cap minus k cap dot 6i cap minus 3j cap plus k cap. So this is equal to 6 into 2 is 12, I dot I is 1, I dot j, I dot k is 0, so forget about it. So 2j cap into minus 3j cap is minus 6j dot j is 1 and k dot k is 1, so it is minus 1 into minus 2 is minus 2. So 12 minus 6 minus 2 works out to be equal to 4. So A bar dot B bar is equal to 4. Similarly, we can obtain mod A bar. Mod A bar is equal to under root ax square plus ay square plus az square. So this is equal to under root ax, x component of a bar is 2, so its square is 4, plus ay is 2, its square is again 4, plus az is minus 1, its square is plus 1. So 4 plus 4 plus 1 is 9, square root 9 is 3. So mod A bar is 3. Similarly, we can evaluate mod B bar, which is equal to under root bx square plus by square plus bz square. Bx is 6, its square is 36, plus by is minus 3, its square is plus 9, plus bz is 2, its square is 4. So this is equal to 36 plus 4 is 40, 49. So root 49 is 7. Root 49 is 7. So we have obtained A bar dot B bar, mod A bar and mod B bar. Use these values in this expression for cos theta. Therefore, we get cos theta is equal to A bar dot B bar is 4 divided by mod A bar is 3 into mod B bar is 7. So this is equal to 4 upon 21. So 4 by 21 works out to be equal to 0.1905. So this is equal to 0.1905. So theta is equal to cos inverse of 0.1905 and this works out to be equal to 79 degrees. So the angle between the two given vectors A bar and B bar works out to be equal to 79 degrees. So that is how we can find out the angle theta between the two given vectors A bar and B bar. So let us see the next problem. Prove prove that the two given vectors a bar and b bar, a bar is expressed as 4I cap minus 3j cap plus 2k cap, and b bar is equal to 3I cap plus 2j cap minus 3k cap are perpendicular. We are asked to show that the vectors a bar and b bar are mutually perpendicular to each other. We have seen one property of the dot product, that when the angle theta, or the dot product of the two vectors a bar and b bar, is expressed as ab cos theta. So depending on what is the value of theta, the dot product of these three vectors can vary between 0 and the product a into b. So depending on the value of theta. So here, if the value of theta is 0, then cos theta will be 1, so that a bar dot b bar will be equal to a into b. But if theta is equal to 90 degree, that is, the two given vectors a bar and b bar, if are perpendicular to each other, the value of cos theta will be equal to 0, so that the dot product of the two given vectors will be equal to 0. So if theta is equal to 90 degree, cos theta works out to be equal to 0, and this implies a bar dot b bar is equal to 0. So now here, if we evaluate the dot product of the vectors a bar and b bar, and if this dot product works out to be equal to 0, then we can say that the two given vectors a bar and b bar are mutually perpendicular to each other. The angle between these two vectors is 90 degree. So let us evaluate the dot product of the vectors a bar and b bar. A bar is 4I cap minus 3j cap plus 2k cap into b bar is 3I cap plus 2j cap minus 3k cap. So the dot product of these two vectors will be equal to 4 into 3 is 12, minus 3 minus 2 is minus 6, minus 6, and plus 2 into minus 3 is again minus 6. So 12 minus 6 minus 6, this works out to be equal to 0. So what we can conclude here is that since a bar dot b bar is equal to 0, this implies that the vector a bar is perpendicular to the vector b bar. The vector a bar is perpendicular to the vector b bar, because when a bar dot b bar works out to be equal to 0, this results only when the value of theta is 90 degree, so that cos theta is 0 and this works out to be equal to 0. So to show that the two vectors are perpendicular, we can evaluate the dot product of these two vectors, and if the dot product of these two vectors works out to be equal to 0, then we can straight away say that the two given vectors a bar and b bar are mutually perpendicular to each other. Okay? Next. Next, ninth problem. Determine the value of P so that the vectors A bar expressed as 3i cap plus pj cap plus k cap and B bar equal to 4i cap minus 2j cap minus 2k cap are perpendicular to each other. Here you are asked to find out the value of P such that for that particular value of P, the vectors A bar and B bar will be perpendicular to each other. So for these two vectors to be perpendicular to each other, it is must that the dot product of these two vectors must be equal to 0. If the vectors A bar and B bar are to be perpendicular, then their dot product must be equal to 0. So let us evaluate the dot product of the two given vectors A bar and B bar. So A bar dot B bar is equal to 3i cap plus pj cap plus k cap dot 4i cap minus 2j cap minus 2k cap, and this must be equal to 0 in order that the vectors A bar and B bar are perpendicular to each other. So this implies the dot product of these two vectors is 3 into 4 is 12, I dot I is 1, minus 2p minus 2 is equal to 0. So 12 minus 2p minus 2 is equal to 0. This implies 2p is equal to 10 or p is equal to 5. So if we substitute the value of p is equal to 5 here, then the vector A bar works out to be equal to 3i cap plus 5j cap plus k cap, and B bar is this, B bar equal to 4i cap minus 2j cap minus 2k cap, and then if we evaluate the dot product of this A bar with this B bar, this dot product must be equal to 0, because for this particular value of P, the two given vectors will be perpendicular to each other. So that is how we can find out the value of the constant used in the expression of the given vectors, either A bar or B bar. Okay. Then see the next problem. Tenth one. Find the projection of vector A bar equal to I cap minus 2j cap plus k cap on vector B bar equal to 4i cap minus 4j cap plus 7k cap. The vector B bar is expressed as 4i cap minus 4j cap plus 7k cap. So you are asked to obtain the projection of the vector A bar in the direction of the vector B bar. So how to find out the projection of a vector in the direction of another vector B bar? So for that purpose, we'll use the definition of the dot product of the two vectors. The dot product of A bar and B bar is expressed as A B cos theta. the dot product of two vectors is expressed as AB cos theta. So when we take, suppose we have this vector A bar and we have this vector B bar, and theta is the angle between these two vectors, then the projection of the vector B bar in the direction of A bar is this vector, and this is nothing but equal to B cos theta. So B cos theta is the projection of B bar in the direction, find the projection of A bar in the direction of B bar. So sorry, here we have to obtain the component of A bar in the direction of B bar. So this is not like this, it should be other way around. So if we draw the perpendicular from the end point of A bar in the direction of B bar, then this is the component of A bar in the direction of B bar, and this component will be A cos theta. So here you are asked to find out the component of A bar in the direction of B bar and not the component of B bar in the direction of A bar. So this component of A bar in the direction of B bar is nothing but A cos theta. So from this we get the expression for A cos theta to be equal to A bar dot B bar divided by B bar, where B is the magnitude of the vector B bar. So this is it. So let us evaluate A bar dot B bar first. A bar dot B bar is I cap minus 2j cap plus k cap dot 4I cap minus 4j cap plus 7k cap. So this is equal to 4 into 1 is 4, I dot I is 1, minus 2 into minus 4 is plus 8, j dot j is 1, 1 into 7 is 7 plus k dot k is 1. So 15 plus 4 is 19. So A bar dot B bar works out to be equal to 19. Similarly, we can find out the magnitude of the vector B bar. Modulus of B bar is equal to under root bx square plus by square plus bz square. So bx is 4, so its square is 16. By is minus 4, its square is again plus 16, plus bz is 7, its square is 49. So magnitude of B bar works out to be equal to under root 81. Root 81 and root 81 is equal to 9. So modulus of B bar is 9. The magnitude of B bar is 9 and A bar dot B bar is 19. So using the values of A bar dot B bar and mod B bar in the expression for A cos theta, we get the component of A bar in the direction of B bar as A bar dot B bar upon B. So A bar dot B bar is 19 and mod B bar is 9. So it is 19 by 9. So this gives the component of A bar in the direction of B bar. So that is about this. That is how we can find out the component or the projection of a given vector in the direction of other vector. So with that, we'll close it here for today, and tomorrow in the next video we'll continue with the problems.